All right, here we go. FRQ Part C. Note, non-calculator. So take your calculator, put it to the side. Not allowed to use it here. Got to do all this math on paper or in your head. So here we go. Make sure that's in view. Here we go. So let f be the function defined in the closed interval 0 to 7. The graph of f consisting of 4 line segments is shown. Okay, this is f. Let g be the function given by g of x equals the integral. Really important to box that. This is, as we know, an accumulation function. Really important to differentiate between g and f here. So let's dive in. We're looking for g of 3, g prime of 3, and g double prime of 3. So g of 3 is going to be g of 3 equals, here is g of x. This is not g of x, this is f. G of 3 is the integral from 2 to x f of t dt. So x goes in for the upper limit. I get the integral from 2, 3, f of t dt. I know the integral means the area underneath the curve. So area from 2 to 3, I'm going to shade that so I make sure I get those shapes right. I see here I have a triangle, and then I see here I have a rectangle. So this would be 1 over 2. That would be my rectangle plus, triangle plus my rectangle. Triangle is a base of 1, height of 2. That's that. Rectangle is a base of 1, height of 2. There we go. We simplify this. This becomes 1 plus 2 equals 3. That's g of 3. Then we need g prime of 3. Well, what is g prime? I want to find g prime first. If I look up here, g is the integral of f of t. So then g prime would be f of x. So g prime equals f of x, evaluated at x equals 3. So this would equal f of 3. And now I can just look at the y values. So f of 3, that equals 2. f of 3 equals 2. That's part 2 of this question. Then I need g double prime of 3. Well, if I know g prime is f, then g double prime would be f prime of x at x equals 3. So this equals f prime of 3. And now I'm looking for f prime of 3, so I need the slope here. Not 2 over 3. I need the slope of this line here. Slope of this line. So let's figure that out. I can choose 2 points on a line to find the slope of that line. So this point is 4, 0. So I'm going to do 0, 4. Then this point is 4, so I'm going to put a 4 here. And then has an x coordinate of 2. So I get negative 4 over 2 is equals negative 2. Let me just double check that math there. I'm going down by 2 over 1, down by 2 over 1. Great, sounds good. Okay. So now I'm in part B. Find the average rate of change of G. Average rate of change, well I know my average rate of change formula is f of b minus f of a over b minus a. So if I apply that to G, I get g of 3 minus g of 0 over 3 minus 0. Average rate of change of G, just like this. Well, I know g of 3 I already have from up here conveniently. So I need g of 0, and then the denominator is easy. So let's find g of 0. G of 0 will equal the integral from 2 to 0 f of t dt. I see my limits go right to left here. I don't like dealing with that, so I'm going to rewrite that as negative integral 0 to f of t dt. And so now this will be negative. Let's find out what the area from 0 to 2 is. Area from 0 to 2 is 0 to 2. That's going to be this triangle here. I'm not going to shade it so we don't get confused. But that will be 1 over 2, because it's a triangle. Base is 2. Height is 4. So this equals negative 1/2 and the 2 cancel, negative 4. So now if I take that to my average rate of change formula here, g of 3, well that was 3, minus negative 4, like that, over 3, I get 7 over 3. That is my average rate of change for part B. So now, let's figure out C. for how many values C